With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. Calculate delta HF naught, that's heat of formation, in kilojoules per mole for C2H6, that's ethane, if delta HC naught, heat of combustion, for C, that is carbon in graphite form, is equal to minus 393.5 kilojoules per mole. Delta HC naught of H2 is minus 286 kilojoules per mole. And delta HC naught for C2H6 is minus 1560 kilojoules per mole. Yeah. So the values of the heat of combustion has been given to us and we have to find out heat of formation. Okay. So when we are talking about heat of formation, definitely, first of all, we will have to plot down the combustion reactions for graphite, for hydrogen, and for ethane. Okay, fine. Because these three values have been given, so obviously from these three reactions, we will be deriving the reaction of the heat of we would be deriving the reaction for the formation of ethane. Okay. So first of all, let us lay down the combustion reactions of graphite, hydrogen, and ethane. Yes, okay. So I guess you're ready. Okay, so the first one is going to be as follows. So carbon plus oxygen gives me CO2. Okay, this is absolutely balanced, isn't it? Carbon over here means graphite, yes, and the heat of combustion for this particular reaction has been given as minus 393.5 kilojoules per mole. Perfect, yes. Now comes in the next reaction. So this is my, say, like equation number 1. Now comes in equation number 2, wherein hydrogen is going to be combusted. So H2 plus half O2. So let me write it as 0.5 O2 for the ease of calculation. Yes. So that gives me 1 mole of H2O. And over here, the delta HC naught has been given as minus 286 kilojoules per mole. Now specifically, I have taken 0.5 oxygen because I need only 1 mole of H2O to be formed. And that is the reason specifically we have taken it in decimal points. Yeah. And the last one is C2H6. Yes. So with oxygen, it's going to give me carbon dioxide and water. Yes. So on balancing, we get 2 CO2 over here. Yes. And 3 H2O on this side, isn't it? Yes. And the number of oxygen would be 2 2s are 4 plus 3 7. Yes. So 7 divided by 2 makes it 3.5. Yes. Again, the same reason, we want it for 1 mole and hence we have presented it in this manner. Yes. So this is how much? Minus 1560 kilojoules per mole. Okay. And that is how much? 3. That's the equation number 3. Now, as you can see over here, the heat of combustion, the combustion reactions have been presented. And from this, as I told you, we would be deriving for ethane. Now, in the third equation, we can definitely see ethane, but it's on the reactant side. So let us do one thing. Let us reverse the equation number 3. Yes. So reverse, or otherwise I would say, invert, isn't it? Yes. Invert equation number 3. Yes. Now on inversion, what do we get? The new equation is 2 moles of carbon dioxide reacts with 3 moles of water to give me 1 mole of ethane and 3.5 moles of O2. Okay. Now since the reaction has been inverted, obviously the delta HC value will also be inverted. So it's going to be plus 1560 kilojoules per mole. Right? Okay. Fine. Now the next part is we are going to add up these reactions one after the other. But before I add up, what I need is that I want to have 1 mole of ethane to be formed, and that would be from, say, like carbon and hydrogen, isn't it? Right? It won't be from carbon dioxide and water, of course. Yeah. So when we are going to sum this up, it would be carbon and it would be hydrogen. Yes. But we have the interfering O2 values, the CO2 and the H2O. Now CO2 and H2O would definitely get cancelled, as well as O2 will also get cancelled, provided I have the same number of moles, right? Okay. So in order to make them same, I would be multiplying each of the reactions by some good factors. Okay. So since I want O2 to be 3.5, okay, total it should be 3.5 on the left hand side, so that I can simply cancel it off. So in order to do that, we have 0.5 already resting over here. So in the first equation, I need 2.5 as the value, right? Okay. So in that case, I'm sorry, since I'm already having 1 and 0.5, so this is going to be 1.5. Okay. So what next do we need is 2 moles of oxygen more, and hence things would be sorted out. Secondly, we want 2 moles of carbon dioxide, okay, and 3 moles of hydrogen. So 2 moles of carbon dioxide and 3 moles of hydrogen. So it's quite simple. Multiply equation number 1 by 2 and multiply equation number 2 by 3. Things will be sorted out. Just have a look. Now remember one thing, while multiplying the coefficients of the reactants and the products, we also need to multiply the value of HC0. Please remember that. Yes, do not forget, or else it would be a mess. Yeah. So the first equation gets renovated. Yeah. And we get 2C plus 2O2. Yes. Giving us 2CO2. Yes. And the delta HC value becomes minus 393.5 into 2. Yes, kilojoules per mole. Fine. Similarly, the multiplication with 3 is going to fetch me 3H2 plus 3 into 0.5. So 3 into 0.5 would give us 1.5 O2. Yes, and 3H2O. Yes. So the delta HC value also changes. So that is going to be minus 286 into 3 kilojoules per mole. Got the point? Okay. Now what we got to do? We got to add them up. All of them. Yes. So ready for addition? So here we go. So as you can see, the cancellation would be taking place. So 2CO2 is on the left, and in the next equation on the right, cancel it off. 3H2O on the left, 3H2O on the right, cancel it off. 3.5. So these two sum up to give me 3.5 O2 on the left and 3.5 O2 on the right. So we can cancel them off. And what remains behind is our desired equation, and that's 2C plus 3H2 giving us C2H6. Yes. Now let us see the value. So we are having plus 1560 minus, let me put it in brackets properly. This became a little messy. Yeah. So 1560 plus minus 393.5 into 2 plus minus 286 into 3. Yes. Equals to 1560. Yes. And that is going to be 5 2s are 10. Yes. And 1 plus 3 is 6 plus 1, 7. Okay. So altogether, just hold on. Let me just write the complete number over here. So this value becomes minus 787. Yes. And minus 286 into 3 would be 858. Yes. So on calculating this, we get minus 85 kilojoules per mole as our answer. Okay, fine. So in fact, What is this value? This is the heat of formation which we have got. So delta HF naught is equal to minus 85 kilojoules per mole for ethane. Yes? I hope you understood the stepwise calculation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.